Life engineering uses machine intelligence to improve human well-being. The starting point is technological development. At the core is quality of life. The objective of life engineering is to achieve a good life with machine intelligence. The following video focuses on homeostasis and learning. Homeostasis controls the behavior of all living things, including humans. Humans perform an action, have a perception, thereby satisfying needs, and experience good or bad connected feelings. Individuals learn from experiences, which actions benefit them and which ones harm them, thus building their knowledge of the world. They do not have to personally undergo all experiences, but can also learn from the knowledge of others. Homeostasis regulates our behavior through needs, as illustrated in the following example. Tom Biber, an architect, has a client meeting in 2 hours. He will be presenting his proposal for expanding the operating theater of a hospital to the hospital manager. Feeling. At the moment, he's hungry and wants to eat something before his presentation. Action. He stops at a fast food restaurant on the way to the meeting and eats 2 hamburgers. Perception. He perceives the salty taste and the feeling of satiety. Need. The perception satisfies the need for food and induces a positive feeling. From his experiences with hamburgers, he has learned that 2 hamburgers taste good before a business meeting, but that a third causes an unpleasant feeling of fullness and fatigue. Feeling, action, perception, and need are the building blocks of an elementary evolutionary control loop known as homeostasis. The feeling of hunger results from a low blood sugar level, an empty stomach, and other physiological signals. Tom knows that he should eat something in good time to be alert for the customer. He also knows that hamburgers taste good and don't take much time, so he stops at a fast food restaurant and eats 2 hamburgers. His taste buds send him signals of a salty and smoky taste, and the increased blood sugar level and stomach pressure signal that he is reasonably full. The pleasurable feeling with the food in this restaurant enhances his knowledge of nourishment, so that he is likely to eat here again. This example illustrates a fundamental evolutionary control loop, homeostasis. It controls the behavior of living organisms with the goal of ensuring that they survive, reproduce, and that the best ones thrive. Homeostasis guides the development of single-celled organisms, as well as, in a figurative sense, the behavior and technology of highly developed living beings such as humans or even entire societies. Feeling, action, perception, and need form an experience and broaden an individual's knowledge, which can also be described as an individual's world model. Part of our knowledge is inherited from our genes, part is acquired through our own experiences, and another part is learnt from the knowledge of others. Knowledge is stored in the brain's network of 86 billion neurons and 500 billion synapses, but also in an individual's physiology, which is also known as the body's adaptation to its environment. For simplicity's sake, we will only look at the processes in the brain. Every action, every cognition, every need, and every feeling generates electrical and biochemical stimuli for certain neurons in the huge network. They change the charge state of the neurons, strengthen synapses, or form new synapses. In neurobiology, this learning process is known as neuroplasticity. Stimuli have different effects on the neurons, depending on how frequent or intense they are. With very strong or very frequent activation, the synapses strengthen in order to enable faster stimulus transmission, or new synapses may even form in order to shorten the transmission path. In addition to physical actions such as biting into a hamburger, thoughts also trigger stimuli. When hungry Tom thinks about a juicy hamburger, his mouth starts to water. If he realizes just before the customer meeting that his design is based on a structural error, he sees the contact being jeopardized, begins to think about his financial situation, becomes stressed, and may even break out in a sweat. Knowledge is not only based on our own experiences, but also on the experiences or knowledge of others. In the case of nutrition, Tom may remember the advert for a vegetarian hamburger. This is just as much knowledge as the algorithm for a statistical calculation. Through homeostasis, people learn from their own experiences. Additionally, they require external experience or knowledge through training, research, or the use of digital services such as mobile apps for navigation. Actions can be of a physical or physiological nature. They cause perceptions that contribute to needs. If the perception fulfills a need, it triggers a positive feeling. If the perception violates a need, the result is a negative feeling. Neurons create feelings by triggering the production of hormones and other physical processes. Homeostasis aligns the behavior of an organism with its needs. In the case of a primitive creature, these are primarily basic needs, such as nourishment and reproduction. In addition to basic needs, humans, as highly developed creatures, have more nuanced needs, such as knowledge, capital, community, and status symbols, which have developed over the course of hundreds of thousands of years, and which the individual acquires through socialization. When the architect Tom Biber prioritizes the aesthetics of his design and wins, his need for aesthetics intensifies in future projects. People consciously and subconsciously generalize actions, perceptions, and needs into patterns of experience and associate them with feelings. The action of eating a hamburger induces the feeling of ordering, paying, and disposing of trash, and develops from repeated experiences. Many perceptions around food condense into perceptual patterns such as salty food and feeling full. The need for food gets refined with every meal to include other aspects such as vegetarian, portion size, and price. The totality of all experiences, our own and those from others, form a person's knowledge. Humans strive for happiness, but the goal of evolution is not human happiness, but rather continued development. Socio-technical evolution utilizes homeostasis to further develop technology and our society. It rewards people when they create more efficient solutions. That is, more efficient in comparison to existing solutions, and more efficient than those of their competitors. Examples include a better navigation app or a more motivating grading system in schools. The architect Tom Biber learns from a mistake he made in the structural analysis of the design, which means that he checks the structural analysis again before the next presentation, or uses a better structural analysis program. Homeostasis and learning are very complex processes. Perhaps the following questions will help us to better understand this mechanism of evolution. Which needs does social media address? Which app enhances our ability to compete? Which actions and needs do we inherit in our genes? Why are these important for the further development of humanity?